Assalamualaikum and hi everyone. In this video, I will show you how to solve exercise 2.6. Question 2.6 asks you to derive a set of mathematical equations that describe the dynamics of the system. Then, using the derived equation, you will need to draw a block diagram. So, let us follow the steps of drawing a block diagram. Step 1 is to determine the input variable and the output variable of the system. In this system, the input variable is f and the output variable is x1. Step number 2 is to do free body diagram analysis. In this problem, there will be two analyses. The first analysis at the mass. The second analysis at the connecting point of spring and damper. Let us do the free body analysis at the mass. Here we analyze all the forces acting on the mass. There are three forces acting on the mass: external force, friction force, and spring force. Therefore, the mathematical equation is F minus Fs1 minus Fd1 equal to md square x1. Now, let's analyze at the connecting point. When force is applied, it will pull the mass and also the other spring and damper. Therefore, there is a displacement at this connecting point. We name this mutual displacement as xm. For the force analysis at the connecting point, the summation of reaction force at the connecting point must equal to 0. This is to ensure the components remain connected together. Therefore, the equations at the connecting point is Fs1 minus Fs2 minus Fd2 equal to 0. Step number 3 is to write all the governing equation for other components. So we have two equations from the analysis, and the other four is the governing equation for individual components. So in total, we will have 6 equations. Now, let's draw the block diagram. From equation 1, we rewrite the equation to become x1 equal to 1 over md square f minus fs1 minus fd1. Using this equation, we draw the block diagram. In this block diagram, I separate the summation point into 2 points. The first summation point is containing 2 input arrows, which is f minus fs1 and also minus fd1. Then for f minus fs1, I draw another summation point, which f is the input and fs1 is another input. For fd1, we use equation 5 to solve it. Then for fs1, we can use either equation 2 or equation 3. Here, I'm going to use equation 2. Using equation 2, we draw a summation point with fs2 and fd2 as the input arrows. Then we use equation 4 for fs2 and equation 6 for fd2. Next is to solve for xm. From equation 3, we rewrite equation 3 for xm, where xm is equal to f1 minus fs1 divided by k. Using equation for xm, we'll be able to solve for xm and close all the arrows. This is the block diagram. if we use equation 2 to solve for FS1. Then, if you use equation 3 instead of equation 2 to solve for Fs, this will be the plot diagram. Okay, thank you.